In this video, we are going to begin the creation of our core input system.
That's right. Now, the input system is really here as our primary translator to get input from classes such as keyboard input and perhaps like gamepad input later on when we create one, and turn that into something that our game understands. Now, to give you kind of a visual representation of this, I'm going to draw some stuff out, really just because I love any excuse I can get to whiteboard things. So let's consider this little box to be our game. So it's got all sorts of things that it can do, man. It can play sounds, it can take in notes, scroll stuff across the screen, but it needs some way to talk to our users. Now, we've already coded one class. Oh, I love that. I love it when that happens. It makes me so happy. We have one class that we've already coded. As I carefully write this in here, this was called keyboard input. Now, we're not limited to just having keyboard input. We could have any number of input devices. So, for example, we could have gamepad input. And, I don't know, I'll make one more just for the fun of it. Let's just do, I don't know, question mark input. From some strange device that we've never seen before that Sony will try to patent later on down the road. Now, none of these guys can really talk to our game directly. The problem is, how will our game know, hey, well, you've pressed, say, the T key. How do we know what the T key is going to do over here in the game? Or on the gamepad, we've hit the A button. What's that supposed to do? So you need some intermediary system to take in all of these inputs and turn them into something that our game can understand. So let me clear off all these silly dotted lines that we don't need. Oh, look, I cleared off more than I needed to. So we get rid of all this stuff. And in between all these guys, we will put in the topic at hand, which is our input class. And it's kind of snug, but we'll fit it in there anyway. Input. Now this guy's job is to actually take in various inputs from whatever kind of input device we have at hand. Could be anything. Could be any number of input things. It's going to translate that into some sort of function that the game can understand and pump that out into our game. So for instance, if the player is playing the game on their PC keyboard and they hit the T key, and the T key just happens to be bound to playing the hi-hat, just as a random example, then the input is going to know that and tell the game, hey, I want you to play the hi-hat. Where if they're playing with a gamepad and they press the A button, and the A button might also be set to play a hi-hat, it's going to know that too, and it'll pump that out to the game.
Exactly. The idea here is to make it so that we have an extensible and modular system where if in the future we add a new input device, we don't have to go through all of our game code, we don't have to go through all of our game screens and update a lot of code to incorporate the new device.
Right. It's just going to take all these inputs and make them speak a common language to our game.
Exactly. And we'll say that that common language for the game is primarily notes. That's the big thing it's worried about, is just a different series of notes. So if we define what that language is, we say that we have notes and maybe a handful of simple functions, like maybe moving up and down in a menu and simple things like that.
Right.
So we define what that internal game input language is.
And part of defining that is that the input class is later on going to be handling our key bindings.
That's right. The keyboard, the input class will take care of saying, okay, the game talks in terms of notes. All these other devices talk in terms of who knows what.
Right.
We're going to make some mappings, and we'll call those key bindings. And that's how we know that, okay, button from device A causes the hi-hat note. Button from device B causes also the hi-hat note.
Right, exactly. So that's all there is to it. I mean, conceptually, it's a very easy system. This is just our translator. It's some way to get all of our input devices to actually talk to the game in one nice, clean, unified system. So without any further ado, let's start coding.
All right, let's jump back into Visual Studio. And let's begin inside of the core folder. Into core, we'll add a class, and we'll call this class input. And let's see, we'll begin with just a bit of namespace cleanup. We need to add in some using statements. So we'll drop in a using for Microsoft.xna.framework as well as Microsoft.xna.framework.input. Now, we're not going to worry about the actual input class just yet. There are a series of data structures that we want to establish to allow ourselves to describe input in terms of the internal game. This is going to be a series of buttons And it's also going to be a struct that will allow us to assign player information and track information along with any given button. So that way that will give us things like multiplayer support. It will allow us to have an unlimited number of tracks.
Sure.
So a lot of nice things.
Basically information the game's going to need to do the things it's got to do.
And then finally we'll put together a class that is going to hold our actual key bindings. So let's get started. All of this is going to take place before we actually get into the input class itself, and we are going to begin with an enumeration. So here we have enum, and we'll call this named inputs. Named inputs was just a...
Do you want that to be named inputs plural?
Yeah, we can do
I'm
that.
sure it doesn't matter,
That
but you
would-
were saying named inputs.
That would follow the pattern with a lot of the XNA types, like keys and buttons
Okay.
and stuff like that. So yeah, we'll make sure that's named inputs. An idea with named inputs is that was the most generic name that I could think of for a button. I didn't want to use the term button because we're working in notes and other controllers have buttons and keys technically don't have buttons, they have keys.
And inputs itself is a little generic because what we're doing is we're applying a name to an input that's coming in.
Exactly, and we have a lot of things already called input. So the idea with named inputs is this is the internal buttons that our game will recognize. And inside of this enumeration, we're going to list all the things that we'll be looking for. So we'll be able to look for an input called up, primarily for menu navigation, down, also for navigation. We'll put in left and right.
For moving the cursor in edit mode.
Right, these won't. Our menus aren't going to generally use left and right navigation, but we will need something in edit mode to move around. We'll have an input called select, which is just a generic compromise between enter and start.
Yeah,
and
kind of like a generic action button.
Right. That's just, it's like the confirm button, and it is in opposition to the back button. So select goes forward, back goes back.
Okay.
And then two more, we have an input called reset, and this will generally be used in the edit mode, also in the record mode, so that if you want to get back to the beginning of a song, we'll use the reset input. And then finally we have what is possibly the most important input, and that is note. So we'll designate that if we get a note, then we'll be looking for a specific note. You'll also see that we're not making notes for the individual drums, because of course if we wanted to, we could make something called like note hi-hat, note snare, note kick, and so on.
Sure.
But the idea is that we don't want to lock in the kinds of tracks that we have at this level.
Okay.
We want to make the system flexible enough that the game really only sees the different drums as generic numbered tracks. And that's it. Though that does mean we're going to need some data to go in addition to this, because note by itself isn't enough to find a specific track. That will bring us to the input data struct. We drop this in place and we'll go over exactly what it does. So I'll have struct input data, and it's going to have a series of fields. It's going to have, let's see, all of these will be public. It's going to have a named inputs field. We'll call that named input. It's going to have an integer called player, and it's going to have another integer called data.
A player I get. I mean, basically that'd be... I guess if it's zero-based, it'd be 0 for player 1, 1 for player 2, and so on all the way down the line.
Exactly.
And what's data?
Data is going to be a generic additional piece of information that can be passed on. For our purposes in the game, it's going to be used to indicate a track in conjunction with the note input.
I.e. what drum we're playing.
Exactly. So in order to play something like the hi-hat, we might pass in note as the named input, and data would be set to track 1 to indicate whatever track has the hi-hat.
Gotcha. So even though we're calling it data, which is nice and generic and totally cool, if you wanted to, you could call it like track.
Exactly.
Or drum track or something.
Exactly. Just for naming purposes, we're leaving this open in case you ever decide that you want to have maybe an intensity fed along with how hard someone's hitting the input button. Just
Sure.
any other theoretical scenario you might want to come up with. Another thing to point out is that this input data struct is the unit of input information that is passed around inside the game. When we thinking about that diagram where we had the input system connecting to the game, it is going to be input data that is passed from input into the game.
Okay.
So whenever the game works on any form of input, it'll be addressing it in terms of input data. And that way we can look into the input data if we're looking for a named input, if we're concerned about what player that input goes with, or if we're concerned about what track, we'd look at the data.
Mm-hmm.
So this input data is simply a way of packaging all of this information into one entity that can be conveniently passed around. All right, moving on, we have the next data structure is going to be a class. We're going to make a class called MapSet. And into this MapSet class, we're going to add a single field. It is going to be a dictionary. It will be a public dictionary. And for this dictionary, we'll specify the key type as an integer and the value type as an input data struct. We'll call this dictionary keymap, and we will go ahead and instantiate the dictionary. So we'll make a new instance of dictionary, pass in the type of key and value, and that will take care of getting our key map set up.
Okay.
Now, what we're doing here is MapSet is really what's going to facilitate the binding and the translating functionality of our input system.
Mm-hmm.
It is this dictionary. It will later be a series of dictionaries. At the moment, we only have keyboard input, so we're only going to drop one dictionary in here at this time. When we add additional devices, we'll add additional dictionaries.
Now you got me doing it. Additional dictionary. There we go.
There's a tongue twister for you.
Yeah.
But we'll have one dictionary per input device, and this will allow us to create our mappings, or our bindings, or you could say our translation, between any type of incoming input, and then pump out an input data for use inside the game.
So where right now we have key map, later on we might have like pad map.
Exactly. We'll have some gamepad map, pad map.
Sure.
And then whatever we need for whatever input devices we create. Now, a quick note on the types used in this dictionary. We're using integer as the key, and the idea here is that we want to map keyboard keys. So that means if we look at keyboard, let's look at a case of this. Here we have the keys enumeration. Let's even load this up really briefly. Let's just go in here, right-click on it, and say go to definition. And inside of XNA, the keys enumeration has a whole bunch of named keys. You can even see the number that's associated with them. And the idea is that we want to bind one of those keys to one of our inputs, which will in turn contain one of our named inputs.
Gotcha.
So that's where the lookup and translation phase comes in. Keyboard key is looked up on this side, which produces an input data struct for use inside of our game. All right. Moving on, we have one last thing to get set up, and that is the input notice delegate. And let's see, before we jump ahead, there is one last thing to address inside of input data. We'll get back to delegate here in a second. When we're passing these input data structs around, it would be nice to be able to create them in line. Meaning, let's say we had a function that takes in an input and a player and data, and we wanted to pass it into the game. Well, we have to package it into an input data struct to pass it.
Right.
So let's give ourselves a constructor that will allow an input data struct to be created in line with all of the proper values. So let's drop down a public constructor, and then let's take in all of the necessary fields as parameters. Take in a named inputs field called named input, take in an integer field called player, and an integer field called data. And then all we're going to do is turn around and initialize all of the fields. So this dot named input will be equal to named input.
Whatever just got passed in for those. Gotcha.
And this dot player will be set to player. And this dot data will be set to data. So simply get everything initialized, and then we can more easily package these pieces of information together. All right, with that taken care of, I think we are ready to move on to the delegate. Now, the purpose of creating an input notice delegate here, actually, let me get the definition typed out. We'll have a delegate. The method that is going to be used in conjunction with this delegate is not going to return anything, so we'll have a return type of void. we will call this delegate input notice. And we will take in a parameter whenever we use this delegate, and that will be of type input data. We'll simply call that input data. And that takes care of our delegate. And this is very similar to our keyboard input class, where when the keyboard input class wanted to talk about input events, it did so in terms of key notice events, key notice delegates. Our input class, when it talks to the game and says, hey, we've got some input, it's going to be in terms of an input notice call. So whenever it calls a function inside the game, it's going to need to follow this method signature.
So the information is literally going into this class by way of key notice and then into the game by way of input notice?
Right, so through the input device, it's getting notified via key notice. Then we get into the input class. The input class reads that key notice, uses this dictionary mapping to figure out what input data that might link up to, then turns around and passes that input data along via an input notice.
Gotcha.
And then that's where our game will be able to read in input from the friendly side of the input system.
All right.
And with that has all of our data structures in place. So we're actually going to pause the video at this point, and we'll pick back up in the next lesson.
Sounds good.